All right, so if you flip over to in your packet, there is a sheet at the top that has a chart on it. And it is going to look like on the top, it should look like this. Okay. So these 9.2 are the graphs of your polar equations. So specifically, we're going to do just a couple of these today. We are going to do the graph of the cardioid, which is like a heart-shaped graph. We're going to do the graph of the lemicon that has a loop to it. And we are going to do the graph of the rows. Okay, so that's what those general forms are going to look like. Sometime on tests, it'll just tell you to classify what type you have. And this is the chart you would want to refer back to. Okay, so this is what we're looking for our pictures to look like today. And you will notice that these have symmetry to them. So essentially, once you find a couple points, if you want to build your picture, you certainly can. Okay, so first thing we're going to do is we are going to turn your calculator to polar form. Okay, so on your graphing calculator, you are going to hit mode. So on your calculator, hit mode, and you are going to go down and you are going to select polar instead of function mode. You'll see there's also a parametric from when you used that in the last chapter. So there's polar. Then you are immediately going to hit zoom 6, but don't expect there to be anything. So zoom 6. And then what we're going to do is change your table into ask mode. So you're going to go second graph. I'm sorry, second, where is it? Second window. There we go. So second window, and you are going to turn your independent variable on to ask. This is just a quick time saver for you to be able to substitute whatever values you want and get the output values right into your chart. So that key was second window. Okay, now you are going to go back to your y equals at this point. And you're going to see that your graph is much different than you are used to. What do you think the R stands for? Yep, just like yesterday, absolutely. So we are going to type in 2 plus. So you have 2 plus, your first example here, 2 cos, and you are going to find theta where you have in the past found x. So if you hit this key, you'll notice it changes it to a theta for you. And I want you to go ahead and hit graph, and then we'll talk about how to actually get these points. So on your graphing calculator, you should have this image. You guys get that? Does it look like a heart shape? This is the graph of a cardioid, okay? But we need to write a table of values to be able to go and create this graph. So I'm going to go back to your paper now and show you how to get some points. And with these, you can get a ton of points, or you can get just enough to kind of get the overall shape to this. There's really, you know, like if you want to do an unlimited amount of these, you really can. So I'm going to go back here, and this first graph is what we call, the classification is a cardioid. So this is a cardioid. And I'm going to set up your table here first, and then we'll put all your values inside of it. Okay, so I'm going to have theta and my output radius that I'm going to let you create the graph of. And I'm going to do a lot of these. All the way down here. Okay. So let me give you a couple of these first to write, and then we'll go back to your calculator to get these values. So I'm going to do 0, and then I'm just again pulling these right off your graph. So 0 is a nice one to do. You could do 15, you could do 30, you could do every single one of these if you really wanted to, but you think that's kind of overkill? Sometimes that's going to be overkill. So I'm going to do 0, I'm going to do 45. Again, you're going to just pick, and if you find you need more of these, you just write more of these. I'm going to do 60, I am gonna do 90. And then let me go back to the calculator and show you how to get these. And then I'm gonna do a lot more of these, but I'm gonna start with that. So on the graphing calculator, you're gonna go to your table. So I'm going to go second and then graph. And I'm gonna start typing these. 0, what am I at? 4. What else did I pick? Did I go right to 30 or did I go to 45? 45. Again, you can do 30, it doesn't matter. So 3.4142 is next. So write them down first. I believe I skipped to 60. That's nice. That's 3. I think I skipped to 90. And then you're going to just kind of build these. So I'm going to write those first couple values in. So at 0, I was at 4. At 45, I was at like 3.4, give or take. And then at 60, I was at 3. And at 90, we were at 2. Again, it's up to you. You can get them all and then plot them or kind of go back and forth. So what this means. Are you in the table, Will? It doesn't look like you are. Second graph. Here, let me go back. Are you in polar? Okay. Guys, plot those points. Let me see what his calculator's doing. You don't have a data. Data. Now you're good. Data's just X. You see it? See the key where you hit X? Yep, you got to have a theta. Sure, no problem. So 0, 4. So I'm going to go 1, 2, 3, 4. And then I'm going to graph 45 as like 3.4. So 1, 2, 3.4. I'm going to graph 60 and then 3. And then I'm going to graph 90 and then 2. Okay, and now I'm going to come up with some more of these. And again, if you want symmetry, you can absolutely grab more of these too. So the next couple values I'm going to grab. How about 120? How about 180? I did 180. Maybe in the middle here, you might want 150. Again, you can do a ton of these. I want 210, so I'm going to go grab those. And then I want 240. Some more, let's go 270. 300. Let's see what that does. I'm going to go back to the calculator and throw all those in and get output values for those, because again, that is your fastest method to do these. Okay, bear with us a second. Trying to go back and forth here. Okay, so now I'm going to do 120. Followed by next one is going to be 150, I think I went. Next, 180. Next, 210. Next, I did 240. I did 270. And 300. Again, if you want more, get more. And then you're going to look at your calculator and you are going to create this image. See how artistic you all are. No kind of challenge with that. So this one was at 1. 150 was a really small decimal, like 0.2679. 180 was 0. 210 degrees was 0.2679. That's kind of why I grabbed that. Those are symmetric. 240 was at 1. 270 was at 2, and 300 was at 3. Okay. So go to your picture watch that yet. Looks like here. I see 150 and a really tiny guy, like right here. So that's like right in here. Then I see 180, 0. So my symmetry is probably going to put that point about right there as well. And then I have next 270 and 2. Like this right here. Did I miss one? Yeah, 240 and 1. That's right there. And then next I have 303. Okay. If you want to keep going, go do 315, go do 330. Or if you've got a good eye, you're going to go ahead and connect this. You are not, again, graded on your artistic ability, okay? All right, it looks something like that. Just pretend I hit this point. Sometimes it's tough up here. So this is the graph of a cardioid. You guys think? How'd they come out? Pretty good? Hopefully better than mine. That's a little lopsided here, but you get the point. Next, we are going to graph r equals 2 plus 3 cos theta. Is this still a cardioid? And it's not. That's what we call a lemicon. And this has an inner loop. So lemicon. That is your classification. And your C has a little wiggly like tail to it. And this has what we call an inner loop. This one's going to have a loop to it. So I'm going to go and I'm going to create my table again. Let me set up the table first. So I'm going to go theta. And I'm going to go radius. And you're going to get as many of these as you feel you need. Obviously, you need a bunch. You don't need a ton. So I'm going to go 0. I'm going to go 30. I'm going to go 45. So I can create an accurate picture to help me draw. 60. Followed by 75. I'm going to do a couple more on this one. 90 is next. I'll go 120. And then how about 150? And I'll stop there for right now. Okay, so you're going to go. You don't need to. Okay, so ready? On your calculator, actually, all you need to do now, which is really nice, is go back to your y equals and change it. In your table with all those values is going to output for this new function. So it's essentially a lot quicker. So 3 cos theta instead. Again, this is a lemicon. So if you hit graph, do you see how it has that loop inside of it? You guys see that in there? I know it's kind of like small, but this is what your picture is going to resemble instead. So it's going to be similar, but you just want to make sure you grab that inside interior loop. And then if you go to your table, you will find that your values have changed for your new equation. You'll also see some of these are negative. And what we did with negatives yesterday is that is just going to go in the opposite direction. Okay. So I'm going to copy this chart right here onto my paper, and we're going to create these points. And you're going to draw your lemicon. Okay. So I have from the calculator, go back and forth. I had 0, 5. I had 30 and 4.5, give or take. So this was 4.5981 if you want this exact, but obviously that's kind of impossible to graph. 45, and I had 4.1213. At 60, I had 3.5. At 75, like 2.7765. At 90, I had 2. At 120, I have 0.5. And here's the one I want you to make a note of in a second. Negative 0.598 is going to go in the opposite direction. Just like yesterday. So this just goes to the opposite direction. anything that comes back negative, because I think 180 was negative, wasn't it? Yeah, -1. So that's gonna again go in the opposite direction. And I'm gonna go, I give you a couple more of these. I want 210 and -0.598 just for symmetry. Again, you do what you need. 240 was at 0.5. And 270 was at 2. And one more. I did 300 is 3.5. But very easy to do. All you're doing is plotting points and then connecting them. All right, so at 0, 5, so I'm going to go 1, 2, 3, 4, 5. I have 30 and 0.5, or 0.5, 1, 2, 3, 4.5, like right here. I have 45 and 4.1, so that's like here. I have 60 and 3.5, 1, 2, 3.5. I have 75 and like 2.7. So 1, 2.7 would be somewhere in here. I have 90 and 2. So there's that section. I have 120 and 0.5. 0.5, yes. That's right in here. You're gonna have to smush it a little bit. And then I have 150 and -5.98. So you're gonna go opposite direction. That's like over here somewhere. I have 180 and -1 opposite direction like this. I have 210 and again opposite direction. That's kind of like in here somewhere. I have 240.5. That's like in here somewhere. I have 270 and 2. Finally an easy one. And then I have 303.5. So 1, 2, 3.5 like this. Okay. I would recommend that you look at your calculator screen when you go to connect these. Again, I will preface this with I am not artistic either, so we will do the best we can. There's my loop. And like this. Okay. How's everyone feel with the Lemicon? Pretty easy? Okay, now you're pretty ones. So if you flip, your last two are your row shape, but they are different. So this first one here, I am given R is equal to 5 sine of 3 beta. So this is going to be the length of my radius. And the 3 is going to pertain to my petals. This is my rows. That is the classification if you're asked to list that. This is your petals. So n is equal to 3. This is an odd value. So because it is odd, that is the number of petals you have. So we have 3 petals. If you are a visual person that thinks well with symmetry, what this means, if I have 360 degrees divided amongst those 3 petals, I have rotational symmetry of 120 degrees. Okay, so that's where those petals are going to come from. So this can go right into your calculator again once I start my chart here. And then it's going to give you all the new output values. And these are fun to draw. Okay, so I'm going to do pretty much the same ones as before. 0 degrees, 30 degrees, and 45 degrees, followed by 90 degrees, 120. Just picking a bunch here. I'm going to go 150. I'm going to go 135. I realize that's out of order. I apologize. and 165 and 180, couple more. I'm gonna go 195, 210, and then I think you're probably, after a couple more, gonna see the symmetry anyways. I'm gonna do 210, I'm gonna do 255, and I'm gonna do 285. And again, you're gonna pull those right off your calculator. I'm gonna go back to the calculator. And I'm going to type in this rose 5 sine 3 theta. Again, it's a good change of pace. It's something you've never done before. So 5 sine, and we're going to go 3 theta. So you go 3, and then the X key becomes a theta instead, and hit graph. What do you guys think? Is it cute? So you have 3 petals just like that. And obviously, as you change your coefficient in front of theta, you will have more petals. Okay, so if I go to my table here, all my output values, so you can copy down as many of those as you'd like. And then I'm going to go and create my picture. Okay, so I have 0, 0. I have 30 and radius of 5. So 45 is at 3.5, so if you want that one. 90, I'm at -5, so again, opposite direction is what that means. At 120, I'm at 0. At 150, I'm at 5. At 135, I'm at 3.5. 165 is 3.5. 180 is 0. 195, again, opposite direction if you want it. 210 is -5. Last two would be 3.5. So 3.5, 3.5. Okay, so let's build this picture. So again, this is called a rose. So we have 0, 0. I have next here 30 and 5. 1, 2, 3, 4, 5. And then on the other side of that, I have 45 and 3.5, which means that right here, I would also have 3.5. So here is your first petal. And then again, you are going to have 120-degree rotational symmetry. So you're just going to kind of keep doing more of these. So down here, I have 1, 2, 3, 4, 5. And then on either side, I am at 3.5. And then 3.5, and then create your image. Yes. And then I have one more of these over here. So what are we at? 150 and 5. So that is 1, 2, 3, 4, and 5. And then you've got those 3.5 again. Okay. And then you are going to sketch this. And that is classified as a rose. How do we feel on that one? Pretty good? Good. Mm-hmm. You can just put 3.5 because obviously there's no way you can even graph with that amount of accuracy anyway, so it's totally fine. And again, your chart just, it depends on how many of these you need once you see the symmetry. Obviously, I want to see a bunch. I don't need every single one that's labeled on this graph. That would be overkill. All right, so one more of these. So this one is still a rose, but what's going to make it a little bit different is your end is even. So this is still the length of my radius, but how many petals am I going to have instead? 8. Good. So n is equal to 4, which is now even, implying that I will now have 8 petals. So if you are someone that thinks in terms of symmetry, 360 degrees divided amongst 8 petals means that you have rotational symmetry of 45 degrees, if you find that helpful. Okay, so now you're going to just make it sharp, a lot more values. I'm gonna go theta, and I'm gonna go r. I'm not gonna go back to the calculator. I think you guys have a pretty good grasp on that, right? So 0, I got 3. I have 45 and 3. I have 90 and 3. Followed by 135 and 3. Followed by 180 and 3. Followed by a couple more of these. Try to give you enough space for your charts. 225 and 3. And then 270 and 3. And then I did 315 and I did 360. 333. Okay, so let's draw. So 0. And then at 45, you're at 3. So 1, 2, 3. And at 90, I'm at 3. Okay, so we got this. Continuing here, I have 135 and 3. And I have 180 and 3. All right, you start drawing wherever you see it. And we're back up. And that way. And I got another 1, 2, 3 here. And more of these, so I have 225 and 3. And I have 270 and 3. So here, here. And my last one is 315 and 3. Okay. And there's my center. Okay. All right, how do you feel with the polar graphs? Pretty good? Okay, if you flip over to homework, I know that some of these are repetitions. It doesn't matter. You have to be able to do them and use your calculator, so I don't have a problem with that. So on your homework, it's not up here though, it's in your packet. So if you flip your sheet over, I want you to do the graphs on the sheet for 1, 2, 3, and 4. But I want you on 5 and 6 to only classify that. Number 5, we might go back and do together tomorrow. So 5 and 6 on your homework worksheet, you only need to classify that, okay? You don't need to create those graphs, just because those take a little bit longer to do. One of them would be the spiral. Okay, but we'll probably do a spiral like number 5 tomorrow when you come back in. So homework is that sheet right in your packet. If you can't read those graphs, there is a large graph paper in the back for you as well. So you use whatever works for you, but I do want to see your tables, please. And then we move on to interchanging between polar and rectangular coordinates tomorrow.